All right, this is notes for 12-2. Okay, here's the key. Right up top. Go ahead and box this. This is your key. This is what you will use as your sign indicator and follow along with the template for each one. This is a plus, this is a minus. Notice these are cubes. Okay? So if it's a plus, like number 1 starts off with a minus. So obviously I'm going to use this guy down here as my example. Okay? So on number 1, so starting off, I need just this part and this part, which is the cube of this and the cube of that. Okay? So we're looking at this guy here. Let's go ahead and make one. What is x to the third? What is the cubed root of x to the third? Anyone? Anyone know?
And this is what you got.
Cube root of x to the third.
X.
X. Okay, following, I'm following my pattern. It says because it was a minus, I have to put a minus. What is the cube root of 8? So what number times itself 3 times gives me 8? 2. Because 2 times 2 is 4 times 2 is 8. Now, once I have this, I now have my A and my B. Okay? I just follow along. So we're on the bottom one because it's a minus, right? So I'll follow along. So it has to be a plus and a plus. So here we go. This one will be longer. Out here. A squared. So this squared. What is that right there squared? X squared. Following the pattern. The formula. Plus A times B. So x times 2 is 2x. Following my formula. Plus B squared. So this guy squared. What is that guy squared? 4. That's it. Done. Don't worry about check. Okay? Check, just basically all that means is multiply it back through and see if you get your original answer. We don't need to do that. We trust ourselves. We win. Okay? Next one, number 2. All right, don't forget about our formulas up here. Okay? Looking at number 2, I know it's going to be a plus formula, so I'll be using that top one. But we're looking at it and going, what number times itself, because clearly it's another cube, what number times itself 3 times will give me 54. Now, we could go through the whole gamut. We know it's not 2 because 2 times 2 times 2 is 8, right? How about 3? 3 times 3 is 9 times 3 is 27. How about 4? So that ain't 54. 4 times 4 is 16 times 4 is 64. Just straight up jumped over 54. So that tells me right now, hey, how about let's just reduce this bad boy? Okay, what number will go into both of these? Clearly there's one number we know that will go into both of them. 2. Why? Because they're even numbers. 2 will go into both of them. You can try other numbers out. You'll find 2 is the only thing that goes into them. So 2. They don't have a variable in common, so I can't take out a variable. What is 54 divided by 2? 27. X to the third. Plus 128 divided by 2. 64. Y to the third. Okay, so now this guy, these are perfect cubes. I can break them down. So here we go. Let's go with the first one. Okay, what is it? It's a plus, so I follow the plus formula at the top, so I know it's going to be a plus here. What is the cube root of 27? What times what is 27? We just did it just a second ago. 3. What is the cube root of x to the third? Just x.
4.
You're jumping ahead. Cube root of 64 is 4. And cube root of y to the third would be y. Okay, so now keeping on tracking, following our formula for the plus one at the top. So we're following this guy here, so it means a minus and a plus. So I'm going to need a minus and I'm going to need a plus. Okay, here we go. A squared. What is that right there squared? 3 squared is what? 3x squared is what? What's that times itself? 9, right? X squared. Because 3x times 3x is 3x squared. Minus a times b. So 3x times 4y would give me what? 12xy. And then finally is b squared. So that would give me what? 16y squared. Done. Okay. Number 3. Okay, number 3 gets a little tougher here, but not too bad. Okay. Does 8 have a cubed root?
Yes.
Yes, and that's a what? 2, right? Okay, because 2 times 2 times 2 is 8. Okay, does x to the 6th have a cubed root? Can you break that down into 3 different things? Yeah,
Yes.
x what? Squared. Okay. Is 125, does it have a cubed root? Is there a number times itself 3 times? That is 5. Okay, so yes, it works out great for us. And because it's a minus, we throw a minus right here in the middle. So you already told me cubed root of 8 was 2. You said cubed root of x to the 6th would be x squared. And then cubed root of 125 is 5. So here we go, our longer one, following the subtraction formula. That means plus and a plus. So we have a plus and a plus. Okay, a squared. What is this guy squared? 4 x to the
Second.
4th, right? Okay. Then plus a times b, so this guy times this guy. What is 2x squared times 5? 10 x squared. And then finally, we have b squared, so 5 squared is 25. That's it. Okay, next one's a little easier. Because I looked at it and go, is there a number that'll cube to give me 15? Well, no, there's a number we could add 3 times to get 15, but not multiply. So we go, okay, let's jump in. Can I take anything out? Anything? Yep, you said 5. So they both have a variable? No, 5 doesn't have a variable, so that's all I can take out. 15 divided by 5 is? 3. And then x to the 3rd. 5 divided by 5 is? 1. That guy there does not have a cubed root. 3 does not have a cubed root. There's nothing times itself 3 times to give me 3, so that guy is done. It also doesn't have a square root. We also want to look for square roots as well. Okay, ready to move on. Flip it. Number 5. And sure enough, I said square roots. Gave you the hint right there. Looking at this guy, there is clearly no cube root, but they are both perfect squares. And it is a difference. So I know right off the top, I can go ahead and I can break this down into 2 groups. One's going to be a plus and one's going to be a minus. The difference of 2 squares. What's the square root of x to the 4th? What does it break down to? X what and x what? X squared and x squared. 81, what's it break down to? What's square root of 81? 9 and 9. Now look at that. I've got another perfect difference of 2 squares. Can't touch this one because it's a plus. It only works on difference. So this one I can break down another time. This one can't. It stays x squared plus 9. This guy here, breaking it down. Square root of x squared is x. One's got to be plus, one's got to be minus. What's square root of 9? 3. And that is as far as it goes. Cannot break this one down because it's not a difference. It is a plus, a sum. Okay. Next one we look at it and we go, okay, 3. Oh, okay, can I square, is there a square root for 3? No. Is there a cube root for 3? No. Okay, can we divide anything out of both of them? And sure enough, we can. What can we divide out of both of them? 3. Do they have a variable in common? No, they don't. One's an x, one's a y. So, when I divide 3 out, it leaves me x to the 4th minus y to the 4th. Now, I have a difference of 2 squares. Okay? So this would be 3 and then double set of parentheses. One's got to be plus, one's got to be minus. Okay? What's square root of x to the 4th? What can I break it down to? x squared and x squared. What square root of y to the fourth? Y squared and y squared. Do you see anything else I can break down? Is there any other differences in squares? Yeah, the last one, right? This guy. It's a difference, and these are both squares. So 3 and then x squared plus y squared. Can't touch that. It's not a difference. This guy, break him down. One's going to be plus, one's going to be minus. What's square root of x squared? What's square root of y squared? That's as far as it will go. Okay. Number 16. I look at it and go, is there square root? First thing we look for is square roots, then we look for cube roots. Square root of 16? Yeah, we can do that. Square root of x to the fourth? Yeah, we can do that. Square root of 32? No. No number times itself is 32. So I go third roots. No, there's no cube roots here. Okay, so all right, what can I divide out of both of them?
4.
I can divide 4, but I could even something bigger.
8.
Somebody said up here. I could do 8, but I could do 16. 16 would be the biggest number, the greatest common factor. What's the greatest? They both have an x in common, so what's the greatest amount of x's I can take out? 2, so squared. So 16 divided by 16 is 1, and then I had x to the 4th, took 2 away, that left me x squared. Okay, minus 32 divided by 16 is 2. Had 2 x's, took them both away, they gone. I look at this and I go, wait, is this a difference of squares? No, 2 doesn't have a square root. Nothing times itself is 2. That's only 1 times 2. So that's as far as it goes. And our last one, we look at it right off the bat and go, oh, might be a difference of squares. And sure enough, they all have a perfect square, right? So make me 2 sets. One's plus, one's minus. What's square root of x to the 4th? X squared. Square root of 49? 7. Even though this is a difference, that's a perfect square? Is 7 a perfect square? No, so that's as far as it goes. You're going to be doing A12-2. You're doing numbers 2, 3, 5, 6, and 9. When you're done, turn it in on the desk. That concludes notes for 12-2.